welcome everyone to the 2 o'clock session. I'm going to introduce myself. I am Nicole Forsgren, and this is what I learned from 4 years of sciencing the crap out of DevOps. So I am the lead investigator on the State of DevOps reports, and I've been studying this area since about late 07, early 08. So back in the day, I was a hardware performance analyst, also a software engineer at IBM. I actually started on mainframes, green screens, which was great. And I also used to manage all of these systems that I worked on, which was a lot of fun until I realized that some of these really large organizations that I was working with that were building all of these systems didn't realize that the people that were working these systems and building the systems were different from my mom that was still trying to figure out email. So I decided to go do my PhD on these systems. And so in all of these years, I've been studying this work, and my goal, particularly in the last 3 years, was trying to figure out how to help the rest of the industry know what actually makes these things better. Because the challenge has always been, when you go to the people in the suits, and you tell them, this company did this thing, or this team did this thing, and usually the dude in the suit is awesome, but that team is not our team. That is not going to work for us. And that made my head explode, right? My head's on fire, and that sucks because I want to be able to say, this is going to work for me. So this is what I learned from 4 years sciencing the crap out of DevOps. So here's what we're going to go over. How to make your data suck less using the science. So much of my work that I'm going to be talking about today is based on survey, and that's fine. That's fine. It'll be fine. We can talk about it. Many of these methods also work with log data. So I was a hardware performance analyst. I can deal with log data, but we're going to talk about surveys today because that's the best way for me to get data from 20,000 data points around the world, usually several thousand at a time in about a month's time period. And how I make sure these survey questions are good with science. I'll talk about what we find, and what we did expect and what we didn't expect. Then we'll talk about some things about continuous delivery, some things about management, some things about culture. This is also going to be fairly interactive. So what I didn't mention in my background is that I used to be a university professor. So I can totally just sit here and wait for y'all to participate. It's going to be great. It's going to be great. Okay, so here we go. So I mentioned that a bunch of this data is based on surveys. So it's fine. I'll go ahead and turn around for this. Who here thinks surveys are shit? There's some hands. Okay, that's totally fair. Totally fair. Who here loves the data in your log files? Not too many hands. Who here has seen shit data in your log files? Okay, so not very many hands, but I'm seeing some nods and some smiles. So the challenge is that a lot of people here have a lot of times when I talk to people about survey data, they're people lie. All of the data that I get out of surveys, people lie. This is all awful data. There's no way I'm going to trust any of it. But many times people are also heart the data in my log files. It's always awesome. But then a minute later, they're don't trust any of it. It's all crappy, right? There are also known vulnerabilities or known really bad open source log systems. So how are we going to deal with that? So here are some of the things that we do. So as I mentioned, I work with survey data for a lot of, or at least for some of the data that I collect, and this is for a few reasons. One is that consider a situation where I would like to collect data from thousands of people around the world, and I can do it through very carefully constructed, designed, scientifically valid and reliable surveys. And I can send you this. And will your management have significant concerns about that? Or I can send you this thing where you install it on your system and you collect data through your backend data, or you collect data through your backend systems and you send this to me. Whose security team is going to allow surveys? And whose security team is going to allow you to send me actual system data, right? That's just not going to happen. So surveys allow me to collect some data. So one way I do this is through latent constructs. So has anyone here heard of the State of DevOps reports? Okay, so we've heard of these. As I mentioned, I'm the lead investigator on these, and what we do is We capture data and we collect data. These are actually designed to be academically rigorous. When I started doing this, I was a tenure track professor and I wanted to get tenure through this data. So these are academically, rigorously designed studies. And one way we collect this data is through latent constructs. So what's a latent construct? There are some things I can collect directly through one measure. One of those measures might be, what's the temperature in this room, right? I can get a number for that. Something that's harder to do is, what is the happiness of a team? Or what is your job satisfaction? That's really hard to collect one number for. What is the efficiency of your deploy practices? It's really hard to collect one number. I can't get a single metric for that. What I can do is collect several metrics that relate to several components or facets of that thing. So think about like the world's awesomest Venn diagram, right? Where we have 4 or 5 things that all relate to, that are drastically overlapping. If I collect all of those, and I know that they are defined concisely, concretely, that's basically a latent construct. It allows me to get several facets of that single thing, measure all of them, go through several steps. That's a latent construct. So the way that I do this, I use Psychometrics to make my survey data good. Or by good, I mean give me a reasonable assumption that the things that I'm measuring are actually the things that I think I'm measuring. So it includes several steps. The first step is construct creation, so that I start with a definition of what it is I'm looking for. I write it up. I write several items, so those items are survey questions. I pilot test it with several people, go through a manual process. Usually it involves like writing each question down on a 3x5 card, several 3x5 cards, hand it to a whole bunch of people, ask them to sort it into piles, make sure all the wording is clear, concise, what makes sense to me and my team might not make sense to 20 or 30 different people. That's the first stage. Afterwards, I go through and I collect all of the data. At this point, I establish validity through statistical methods, where validity is, there's discriminant validity. I make sure that it doesn't measure anything it's not supposed to measure. And convergent validity, I make sure it only measures the things it's supposed to measure. And then reliability, it's basically a way to make sure that everyone is reading it consistently and the same way that they're supposed to be measuring it. So after I've gone through all of these steps, notice I'm still measuring all of these things. I haven't even started looking at how the items relate to each other yet. Now, I measure all of these things before I even start looking. But before that, I even start figuring out what things should I include in my study, right? So sciencing means I should take a look at some of this stuff. So this includes things like what should, so in DevOps we know that technology is important, we know practices are important, we know culture is important. People always say culture. So what do we mean by culture? So I go back in the literature, right? So with culture we mean, well, is this just intuition? Like, do people just say culture? Or does it actually matter? Go back through a couple decades of research. No, culture actually matters. But which kind of culture? So one kind of culture is national identity and norms. Do I want to investigate that? Well, there's also adaptive culture. Do we want to look at a culture that values learning? In the 2014 study, we did take a look at a culture that values learning and found that it was important. But we really wanted to take a look at a culture that values information flow and trust. And we found this to be, by the way, important in the 2014 and 2015 studies. We also included it in the 2016 study. So we really took a look at this one. So we looked at some of the work by a gentleman named Westrum. He's a sociologist out of the UK. And here's where it's interesting. So we're going to go through this. Here's why we picked this. There's a citation at the bottom. It's a typology of organizational cultures. Why did we think this was even going to be important? Why did we think it was going to apply? Well, Dr. Westrum did his work in healthcare aviation, highly complex, high-risk environments where information flow and trust is very important. It tends to predict performance outcomes. It also tells you what happens when things go wrong. This, by the way, tends to be a really good corollary to technology, right? Piece of my dissertation argued that these types of things that are highly complex, high risk, important explanatory power, when things go wrong, would be a good fit for technology. So this is why we picked this one. So let's take a look at explaining, so this is actually pulled straight from his paper. Generative performance culture is typified by high cooperation, messengers are trained, risks are shared, bridging is encouraged, failure leads to inquiry. This is a 2004 paper. This sounds a lot like DevOps cultures, right? Is this sounding pretty familiar? Who here works in kind of a generative culture? Does this sound familiar to any of us? Bureaucratic culture, modest cooperation, messengers are neglected, narrow responsibilities, failure leads to justice. By the way, generative culture is seen in about a third of the organizations or teams that we study. Bureaucratic seen in about 55%. Who here has a friend that works in a pathological culture? Low cooperation, messengers are shot, responsibilities are shirked. Okay. So we were thinking I would like to turn this into survey questions. Here's how we write a survey question. It needs to be strongly worded. It needs to be a statement. So like question, right? I already said that wrong. It needs to be a statement, one for each line, where the responses can be strongly disagree to strongly agree. Strong statements, clear language. So what might these look like? One for each line. So here's how we did this. On my team, information is actively sought. On my team, failures are learning opportunities and messengers of them are not punished. On my team, responsibilities are shared. On my team, collaboration is encouraged and rewarded. On my team, failure causes inquiry. And on my team, new ideas are welcomed. The great thing is that this has been found to be valid and reliable from a statistical point of view. And it is predictive of both IT performance and organizational performance, where, by the way, organizational performance is like dollars, right? Money. So anyone here can use this to measure organizational culture on your team. Give this to your teams at 6 questions where a 1 is strongly disagree, a 7 is strongly agree. We see several teams in industry now using this to evaluate their own teams on a quarterly or maybe even like twice yearly basis. Because we see that as culture starts breaking, technology starts breaking. We see this in several different contexts. A friend of mine, Janet Vertesi, did her postdoctoral work at Jet Propulsion Labs. Tangent, by the way. But it was really interesting because she studied the Mars rover mission as well as the Jupiter Cassini mission. So they have the teams, the robots leave, right? The teams start fighting, so especially Cassini. So the Mars rover mission, they had this really interesting thing where at the end of the meeting, every scientist around the table had to say, I am happy. And they had to actually be happy. Mars rover was supposed to live for like 6 months and it lived 11 years. Lived, right? It's a robot. Anthropomorphizing here. The Cassini mission, Cassini left, and every time you want to take a measurement on the planet, you have to actually like move the robot. So they have to agree ahead of time. When the team starts fighting, the robot starts breaking. So this is a very, very real thing, right? So Conway's law is for real. So culture is a good thing to keep a pulse on what's happening. And we can do this now with 6 items. My nerd proud moment is a few months ago, Dr. Westrum emailed me and he said, I hear you've been using my work. Can I see what you're doing? And I emailed to him and I got a little nervous because I'm like, did I do it right? And he emailed me back and he said, this is really good. Like you're applying it in very intelligent ways. Yay. Okay. No, so here we go. Here's an example for some of our analysis. So we had a hypothesis that notification of failure would be an important piece of understanding our technology and how we do our work. So these were the items that we came up with. At my organization, we're primarily notified of failures by reports from customers. We are primarily notified of failures by the NOC. We get failure alerts from logging and modifications, monitoring systems. We monitor system health based on threshold warnings, and we monitor system health based on rate of change warnings. Now, remember how I said ahead of time, when I do pilot testing, I do like a card sorting task with people? There's a statistical way to do a card sorting task. And that's when I do like convergent validity and discriminant validity. So what happened was I did my statistical card sorting task. So this was original in 2014. There was a surprise in my statistical, it's called exploratory factor analysis. There was a surprise in my card sorting task, my statistical one. Can you spot what that surprise was? I'll tell you right now, they didn't sort together. They didn't end up in one pile. They ended up sorting into 2 piles. So I had to guess at what this was. And we realized that there was notification of failures from close to us, near, and there's notification of failures that are farther away. So now when I do the analysis, I now have 2 different latent constructs. Guess which one of these is more predictive of success? Near, right? Exactly, because I know sooner. Because who wants to know that who wants to find out from Twitter that things went down? We thought it would be the same thing, because at least we're getting notified. It absolutely sorted into 2 piles.
How do you sort those piles?
Exploratory factor analysis. So like thousands of people took this survey, did all the data. So I ran this through 15, I think it was 17 people, and they're like, oh yeah, it's all notification of failure. Looks great. Thousands of people, however, based on their responses said, no, we conceptually understand this to be 2 different things. Which now that I read it, I'm like, well, of course it's 2 different things. It is notification of failure, but it's notification of failure from 2 different proximal sources. So this is where, my hypothesis was a little wrong. Okay. Oh, and by the way, there are more data tests. So I also check, common method variance. I make sure there isn't bias inserted into the data just due to the fact that I'm only collecting data from surveys. I also compare early and late respondents to make sure that there's not something significantly different between people who are answering it super early and answering the survey super late. I also check for survey drop-off rates and bias to see if there's anything happening in the data there. I will mention there is one more thing as well in terms of when I talk about prediction correlation. You have to meet one of 3 conditions in order to test for prediction anytime in data. One of those things is you can do longitudinal data analysis. I don't have that in this data because it's a cross-sectional study. I only have survey. So even though I have it 3 years in a row, 4 years in a row, I don't have matched data sets, so I don't meet that condition. Another condition is randomized study design. I don't have that because it's just a survey. This is a non-experimental survey design. The third condition that I do meet is theory-based design. So this basically says I have a hypothesis. I believe that there is reason to believe this relationship exists, so then I can test it. If I don't meet that condition, then I can only report correlations. This keeps me from doing something like fishing for data and looking for something. There's this wonderful website called spuriouscorrelations.com that shows, for example, the number of pool deaths in the country goes up every year. There is a Nicolas Cage movie that comes out. One does not predict another. Sometimes we just find random things in the data. So anytime I report on a prediction, it is because there is a reasonable expectation. There is an explanatory reason for that to exist. So if I report a prediction, it's because I do meet that condition. Otherwise, I only report correlations. Okay, now we can look at the data. So, that's just what I talked about. So when I meet this condition, I do report on a prediction if the math fits. Otherwise, I only report on correlation. So one key finding that we do have in the data is on IT performance and its behavior. So starting in 2014, we do define IT performance, which is really exciting. And IT performance is a combination of throughput and stability. So throughput we define as lead time for changes, which is code commit to code deploy. and release frequency, as well as stability, time to restore service and change fail rate. This is a really great metric because it speaks to both of our communities, right, developers and operations. It's also nice because these are measures that are sort of at tension with each other, so it's really hard to game this metric. The really great thing that we see 3 years in a row is that these move together. They move in tandem. For years, we've heard this suggestion, we've had this little either a little angel or a little devil, someone on our shoulder telling us that you have to have trade-offs, right? We've been told for years that you must slow down in order to get stability. I don't see it anywhere in the data. These two move together. So this has appeared in peer review. In a conference paper, we're also working on a journal paper in progress right now. The other really, really great thing is that IT performance matters. So firms with high-performing IT organizations are twice as likely to exceed profitability, market share, and productivity. The other nice thing that was super exciting is that IT performance is predictive of organizational performance. So this is not just correlation, this is prediction. IT performance over the years, in particular deploy frequency, has really shot up over the last year. In terms of stability metrics, we don't see a huge amount of change because slow is the new down, right? You just can't get much more stable, but we are seeing a huge impact and a huge increase in terms of speed. Now, continuous delivery. We're seeing some exciting things. This is based on partial least squares analysis. So this is basically a prediction model. So you can read this by saying, so the items on the left make up continuous delivery. So these are technical practices that are important for IT performance. So test and deployment automation, trunk-based development and continuous integration, and application code, application and system configuration, all in version control. Once you get to continuous delivery, every arrow after that you can read as prediction. Predicts, drives, impacts. It drives IT performance, it drives lower change fail rates, and the part that I really love here is that it decreases deployment pain. It also drives organizational performance, profitability, productivity, market share. So we can really, really see how this is important. So how can we get our IT performance and our org performance better? Which technical practices are important? Right there. And then with math. If anyone wants to come talk to me, this is, again, based on PLS. The other thing that we found in this is that it also decreases burnout. Now, for the 2016 study, we expanded the definition of continuous delivery, so research is kind of an iterative process. You take it a step at a time. This year we added effective test data management, trunk-based development using a monorepo, and explicitly we added shifting left on security. Found all of those to be predictive. The other nice thing that we found here, so the things in bold are added, it decreased the amount of rework that teams were having to do. And it increased identifying with your team. So how excited you were to work on your team, how excited you were to be a part of your organization, which really led to a virtuous circle, right? We know that when we're doing really exciting work, we want to keep doing that work and we want to keep being a part of our team. And this predicted higher org performance as well. Some surprises. So here we can go through. So what's not strongly correlated with IT performance? Any guesses here? Third-party scripts, homegrown scripts, commercial CM tools, open source CM tools, golden images. Everything in red is not correlated. Commercial config management was negatively correlated. Open source, highly correlated. Now, this is based on that statistical card sorting task. Which ones did not load together? Which ones basically just fell out? Any guesses? Which ones measure effective test practices? Which ones don't load? Which ones are not like the others? And again, surprises, right? Anytime you do research, there's going to be some surprises. anytime we move tests outside, we just don't see as good a performance. Okay, let's do another one. Change management. Which one falls out? Which one is different? Now, the R at the end there means it's reverse coded. So all production changes, so no production changes have to be approved by an external body. That means I reverse coded it on this statistical analysis. So the one that's different is only high-risk changes, like database changes. The reason this one might have fallen out is because it introduced something new, like a database change, right? That may have just been too different from the rest of them. So what happens, by the way, when it falls out is it means I remove that item from the analysis, and then I move forward. Okay, some surprises with culture. We wanted to add the Google study. So as a reminder, these were the Westrum culture items. If you take a look at the left, Google did this fascinating study, and they found that what really matters in team performance is team dynamics. So these are, this was the results from the Google study. We also wanted to add identity. I mentioned identity earlier. So this was adapted from Concanali et al., some findings from MIS research. And so we added items. We turned the Google study items into new items. We added identity items. What was really interesting, some surprises, is that we found that the Google study items actually split in half. They loaded on two different constructs. The top two loaded with Westrum items because they really speak to trust. They talk about team dynamics. The bottom items loaded with the identity items. They spoke to meaning, impact. So moving forward, what that meant was with the rest of the study, we just couldn't use the items that we built off of the Google study. And we retained the Westrum items and the identity items through the rest of our analysis. Although what that also means is that Google's findings speak to both the importance of structure and clarity, meaning, impact, identity, and team dynamics and trust and information flow. A few management findings. There was something really interesting. When we went back to the 2014 study, there was some interesting correlations showing that managing WIP was important, but it didn't seem to explain very much. The correlation between WIP and IT performance was negligible. It didn't really tell us very much at all. So we wanted to know what was going on. It turns out that if we include WIP, effective WIP limits, if we include it in a larger construct of lean management, then it becomes more meaningful. So what we found was that lean management is comprised of WIP limits, use of visual displays, and monitoring to make business decisions. These are all predictive of IT performance, decreasing burnout, and improving our culture. And that these drive organizational performance. In the 2016 study, we went further upstream into that fuzzy front end, and we found that gathering, broadcasting, and implementing customer feedback, as well as decomposing work into small pieces so we can get that single piece flow, and making that whole work stream visible was important in identifying strongly with the business, contributing to culture, and increasing IT performance, as well as decreasing deployment pain. So, conclusions. Even if you think it's obvious, test with data. If the results don't surprise you, you're doing it wrong. If you don't confirm at least something, you're doing it wrong. If everything surprises you, you're doing it wrong. If nothing surprises you, you're doing it wrong. We can have it all, at least in terms of throughput and stability. DevOps culture, technical practices, and management practices have a measurable impact on IT performance and organizational performance. We can see it in the data. It's not just a handful of teams. We're making a difference. Thank you so much.